Andrew White, co-founder of CHAR Technologies. He has an MSc degree in chemical engineering from the University of Toronto, and after a eureka moment in the lab, launched CHAR Technologies. He also has a master's degree in business entrepreneurship and technology from the University of Waterloo and has won the IBK Capital Ivy Business Plan competition, been named the OBBA's Young Entrepreneur of the Year, and led CHAR to be named the CIX Top 20 Most Innovative Public Companies. Andrew.
Perfect. Thanks, Mark. Appreciate it. And it's my pleasure to be here. Thanks for having me. As we go through this quick 7-minute presentation here, I'd like to just take the opportunity to introduce CHAR in general, and then, of course, look forward to questions and the panel discussion after. The key here is that we are an industrial clean tech company, so our focus is really on the industrial aspect. And to do that, our firm is split into two operating groups. One is called Alltech. It does environmental compliance and engineering work, and CHAR Tech Solutions, which is our technology group. And the importance of this is all of our industrial clean tech systems require permitting. We have that permitting capability in-house and the ability to share our process engineers, which is a very good advantage when deploying these systems. What I'd really like to talk about is where our future is, and it sits in our high temperature pyrolysis technology. So at a high level, this graphic on the right explains what high temperature pyrolysis is, but essentially we take challenging feedstock, so things like digestate, so that is residual from a renewable natural gas biogas plant, biosolids, residuals from wastewater treatment plants, manure and compost, woody material, agricultural material, and we put it in this pyrolysis system, which essentially cooks the material. High temperature, so about 800 degrees Celsius, long time, about 30 minutes. It's a continuous process, so it takes about 30 minutes for the material to move through the system, and oxygen free. And the oxygen free is critical because it allows us to thermally convert these feedstocks into two co-products. One is clean energy in the form of a pyrolysis gas or syngas, which I'll talk a little bit more about. And the other is our biocarbon, so the solids. So we're taking these challenging waste streams and converting them into two marketable products. And so this is what a plant looks like. This is our pyrolysis plant in London, Ontario. It is producing some of our biocarbons, the primary one here being Clean Fire. We recently announced the 1,000-ton order to make Clean Fire out of wood waste, and it's a biocoal that is going to the steel industry to offset fossil coal in their blast furnaces, so that's very exciting. The other important aspect here is the bullet that's in red that says energy generation. Once the plant's operational, it produces excess syngas or pyrolysis gas, so it can fuel itself. It doesn't require any fossil fuel inputs once it's operational, so it has a very low operating cost as it's running. On the gas side, we have two potential fantastic market opportunities. One is in the renewable green hydrogen space. You can see this diagram on the bottom. This is from Ontario's green hydrogen strategy, and biomass into green hydrogen is identified. It's something that we're actually already producing. So we don't need any more R&D. We're there and we're ready to capitalize on that market. And we do have a proposed facility in California that'll be producing about 100 kilograms per day of hydrogen from some of these challenging biomass streams. The other is renewable natural gas. And the key takeaway here is that the third bullet point down, that over 80% of renewable natural gas in Quebec has to come from second generation technologies like ours in order to meet their RNG targets. So they have a target in 2030 to have 15% of the natural gas on their grid being renewable. And the only way to meet that target is to use technologies like ours. The kind of first generation anaerobic digesters, for those familiar in the market, companies like Greenlane or Zeebec that upgrade those gases, they're fed by organic waste, and there's just not enough organic waste to meet this high gas production requirement. But fortunately in Ontario, Quebec, BC, New Brunswick, there's a tremendous amount of kind of underutilized and sustainably harvested forestry material. The final output product that we have is our biocoal. This is the product that we just announced a large order for. And really what it's doing is offsetting fossil coal. Blast furnaces at steel mills must use solid carbon, and they've got two options. One is fossil coal and the other is biocoal. And the reason for the switch is 1 ton of fossil coal gives you 3 tons of greenhouse gas emissions. 1 ton of clean fire, our biocoal, can offset 1 ton of fossil coal. So essentially we can reduce their greenhouse gas emissions by 3 tons with each ton of our product. And the amount of material that's consumed is very substantial, and they have no choice in the matter. The chemistry of a blast furnace requires solid carbon. And so, as I said, on March 17th, we announced this 1,000-ton order, which is really a key market validation step for the use of our clean fire product. We do have a secondary market. That's in the treatment of biosolids. Really, the important point here is the second bullet on the left in the center, that landfill costs are increasing due to PFAS. PFAS is polyfluorinated alkyl substances. It's really the contaminant of concern in the US. Aaron Brockovich talks about it. There's a Hollywood movie, Dark Waters, about it. And really the challenge is that the presence of PFAS is driving landfill costs up substantially, which is really changing the market dynamics around how to get rid of biosolids. And of course, the pyrolysis technology that we've developed destroys PFAS, so those biosolids can be managed more sustainably and safely. So from a business model perspective, at our core, we're EPCM technology providers. Depending on the market, we're either owning part of the asset under a utility model, and in some cases, we're just selling the equipment depending on the market opportunity. We also have a pretty substantial insider ownership, and I would say the market is starting to pay attention to what we're up to. So with that, my timer shows exactly 0 seconds, so hopefully I didn't rush through it too quickly, and I'm obviously looking forward to the panel discussion. Thanks a lot.
Well, you're about 8 seconds early there, Andrew.
I hit start 8 seconds early, I guess.
Well, thank you very much, Andrew. And let's bring back Rob and Darwin for the Inquisition. And so all of you are fully funded for your next round of work. So let's start with describing with what you plan on doing with those funds. And I'm going to start with Andrew with an explicitly, you just closed a $6 million private placement, but have an operating cash burn. What will be your use of proceeds over the next 6 or 12 months?
Yeah, so this is, a big step for CHAR is this $6 million financing. We're very close to EBITDA neutral, sort of by design with COVID going on. We were able to bring stuff down, but now that we've got a nice balance sheet, we're able to start investing. And it's really in 3 core areas. One is our human capital, so bringing up our engineering capacities. We're in the midst of a pretty exciting hiring round right now. Second is working capital, just to get these projects off the ground. And third is developing some of these utility model projects. Our sort of cost of entry for the equipment isn't so substantial that we're able to start to deploy equipment now.
And can you give us a sense and division of between working capital, salaries, and for project allocation?
Yeah, about 2/3 project allocation. That'll let us get some deployments, and the rest between salaries and working cap. We have a pretty light, tight cash burn, so we're able to put a lot into the equipment.
Okay, thank you. Andrew, can you tell us a bit more specifically about the Capex for a unit and the projected operating costs and other economics around a unit? And maybe, obviously, they'll be of different scales, so maybe give us a particular scale design and then work from there.
Yeah, absolutely. So, the kind of base kiln size, module size is 3.5 tons of material input. So let's call it wood. We're creating renewable natural gas and biocoal. So that unit is on the order of $10 million to process that material. It will produce approximately 5,000 tons per year of biocoal and will produce approximately 200,000 gigajoules of renewable natural gas. And so when we put some economics around it, renewable natural gas has a pretty big premium on it. So we're talking in the $20 to $23 per gigajoule range. And the biocoal right now, we're pretty competitive at about $300 a ton. So that gives you kind of an idea of the overall economics. From an OPEX perspective, the really big OPEX numbers are personnel and feedstock. As I sort of mentioned in the presentation, the system is autothermal, so it produces enough energy to create the heat that's needed to process the material. So the utility cost is almost inconsequential. It's what are we getting our feedstock at, and whether it's a waste product that is kind of a zero cost, or whether it's a woody material that is $20 or $30 a ton. And are we co-locating with an existing facility that allows us to borrow some labor so that we don't need to, fully staff the system ourselves, or is it a greenfield development? And those are two, really big levers on the economics around each one of these systems. And then being modular, 3.5 tons is our biggest kiln. And then we do modular operations. And the primary reason for that is it allows us to build the systems in a factory acceptance, test it, skid mount it, and just ship it to site. So we avoid a lot of the uncertainty around on-site construction and commissioning that has been a struggle for renewable natural gas facilities historically.
So two follow-on questions. One is I didn't do the multiplication spreadsheet in my head fast enough as you gave the numbers, so I dropped one from my memory. What would be the total revenue on an annual basis based on your assumptions for the $10 million plant? And what do you anticipate in terms of depreciation and refurbishment costs? Have you factored that in as well?
Yeah, so rough numbers. Again, it depends a little on what the gas offtake contract is, but you can peg it in the neighborhood of $5 million in revenue per kiln train. Depreciation is not as substantial as perhaps one would think, because it's a fairly robust system. It's a heat tube that rotates, some feed screws, so there's a couple motors to lubricate. There's some flights to repair. So we've targeted that at about $150,000 to $200,000 a year in, maintenance, repair, replacement parts. The heat tube has to be replaced every 5 years, and that's factored into that pricing as well. So there's not a lot to go wrong, which is pretty important for the robustness of the operation.
Okay. And Andrew, in terms of the asset, not ramping up your business, but the value of your technology asset, going forward, is your expenditure focus going to be on improving the manufacturing of it and its operating capabilities? In other words, optimizing cost and performance? Or is it on taking the technology a step further and perhaps a next generation of units?
Yeah, so our focus really is on deployment, and so it would definitely lean more towards the optimization side. We're getting kilns out in the field, whether it's making green hydrogen, renewable natural gas, processing biosolids, those kind of three market areas. And there is, of course, some overlap on what we process and what we make. On the development side, it's really more about determining how to continue to add value to our biocarbon, our output product. Right now, whether it's a biochar that's kind of a soil amendment, or a biocoal like the one we recently announced that we're supplying, those tend to be lower price, high volume materials. We know that there are some very high value opportunities for the carbon, and that's where a lot of our development work is going to be. As I said, the equipment is pretty robust as it is. I'm much more of a fan of robustness versus tweaking and adding unit ops, and it's kind of a diminishing return when you start to play that game. But as we change our processing conditions, we can find some markets where instead of $250 a ton for biocarbon or $500 a ton, we can get into $1,000, $2,000 per ton, much higher value markets. And that takes a little bit more work to get us there, but that's what our R&D budget is going to be primarily focused on.
Very good. Now we're into the final two questions for each of you as a group. And the first question is, we can often get, as investors, a good insight into your thinking by what you choose not to do. So each of you have an opportunity which is attractive, but it's either a market opportunity or an asset that you are not prioritizing at this time. So please tell us what it is and why you're not prioritizing it. And let's go with Andrew, Darwin, and Rob.
Sure. So for us, the big pyrolysis news in the last kind of 6 months has been pyrolysis of waste plastic. It seems like every pyrolysis company out there wants to chase waste plastic, and we're not focused on it for two reasons. One, everyone else is doing it. So, we're a little, I don't like to jump into markets that are that established. I guess I'm more of a blue ocean kind of thinker. And the other reason is the plastics create bio-oils, which there have historically, kind of 10 years ago, been a number of pyrolysis companies that tried to produce bio-oil and failed for a number of, well-documented, established reasons. So, we know we're producing nice, clean syngas. We know it gets into green hydrogen. The premiums on green hydrogen or renewable natural gas are there. And so that's where our opportunity and that's where our focus remains.